This session we'll be learning about deadlock. So one of the most important topic in university examination and GATE and any kind of public sector undertakings. So what exactly the meaning of a deadlock is? You imagine a situation that when there are few processes by name P1 and P2 and they hold some resource, the resource name is X, and P2 holds the resource by name Y. Here resource may be a file, a resource may be an address, resource may be a memory, anything it can be. There are two kinds of resources we know, hardware resources and software resources. So here P1 holds resource X, P2 holds resource Y, but P1 also needs resource Y to get completion of its execution. Then in this case, P1 put a request to P2 that or operating system, whatever it may be, P2 requests to operating system that I want a resource Y. But resource Y is unavailable. Then immediately OS comes to know that it already held by P2. Then immediately it responds. Immediately it responds to P1 that you have to wait. This is scenario 1. Scenario 2, in this case, there is a process P1, there is a process P2, there is a resource Y, and there is a resource X. X is already allocated to process, Y is already allocated to this process. Now P1 needs the resource Y, so it is keeping a request to operating system that I want resource Y. Again, operating system re-verify whether resource Y is freely available or not. As this is not freely available, just your request edge becomes. This is your request edge. Your request edge becomes a waiting edge. Your request edge becomes a waiting edge. So you're supposed to be under waiting. Now, P2 also needs resource X. It contact operating system that I want resource X. Again, operating system verifies that X is already held by P1. Then the request edge, which is given by P2, becomes a waiting edge. What exactly the meaning of this? This is already assigned. Y is assigned to P2. That's why Y is holded by P2. X is already assigned to P1. Therefore, X holded by process P1. In this case, both processes P1 and P2 are waiting for each other indefinite amount of time. This forms a cycle because it is a never-ending process. P1 won't release resource X, P2 won't release resource Y, then it forms indefinite waiting or indefinite starvation leads to deadlock situation. This is what exactly the meaning of deadlock. Now, you can also take some example that real-time example. There is a four-corner road. Vehicles are passing in single direction. Vehicles are passing in single direction. This is a vehicle A is going like this. There is no other way. And this is a vehicle B which is going in this direction. There is a vehicle C which is going in this direction. There is a vehicle D which is going in this direction. Now see, if you observe that it is going like this, and A is also going and B is also going like this. So this creates a cycle. If there is any traffic jam, then unless B is moving, A cannot move. Unless A moves, D cannot move. Unless C cannot move. This is how they are, because A is holding this line. Please observe. A is holding line A and it is waiting for line B. It is waiting for line B. B is holding line B and it is waiting for line C. C is holding line C, then it is waiting for lane D or line D. D is holding line D and waiting for line A. If the vehicles are moving, no issues. If there is any blockage, then the issue becomes bigger. So this concept is called deadlock. They are waiting for each other in circular wait fashion. What is the meaning of circular wait? A is waiting for B, B is waiting for C, C is waiting for D, and D is waiting for A. So this is a generalized example where you see four-corner road. So a deadlock is a situation in which a group of processes becomes permanently blocked indefinitely. Each process holds one or more resources needed for execution. Every process is waiting for other particular resources to acquire, and this is never possible, which leads to permanent blockage. This permanent blockage is concept called deadlock. So none of the process can proceed further because other process needs you, whatever the resource you had. So deadlock assumptions. It is only possible because of finite number of resources are there. According to our previous example, this one, there is a resource very limited. Why I say that limited resources? Because you are having a one lane only. For example, if there is another lane is available, vehicle A, if at all it knows that the B lane is blocked, then it could able to traverse in other direction. If at all there is any other lane which is connected to this, if a B comes to know that the lane C is blocked, then it could able to traverse in this direction. If you provide infinite resources, there is no concept of deadlock. But when you are having a limited resources, and that too those resources are shared among the processes, and the process need each one of them to get completion of their execution, then it leads to a concept of deadlock. So that's why if there is a finite amount of resources and resources are categorized into various types, each resource has got identical types of resources, and if the finite resources are blocked by other particular process, then it leads to a situation called deadlock. But imagine there is a one big difference I want to say. Starvation is different and deadlock is different. Many of the students used to get confused here only. What is the difference between starvation? If a process 1 is waiting for a resource X, but resource X is already assigned to B, it is already assigned. Rx is assigned to B, but P1 is requesting. But P1 requesting for resource Rx. In this case, P1 request edge becomes a waiting edge. P1 request edge becomes waiting edge. What does it mean by that? As soon as B completes its execution, Rx will be deallocated, then that Rx can be given to P1. But I don't know when I'm going to get the chance. I don't. That means P1 do not aware of that. When the Rx will be released by B, that concept is known as starvation. But deadlock is different. What is the deadlock situation? Bidirectional starvation is needed. What is a bidirectional starvation? There is a process P1X. There is a process P1 is requesting for Rx, but Rx is already assigned to B. Rx is assigned to B, and B is requesting for resource A. B is requesting for resource A. It already given to P1. It already given to P1. Then in this case, what happened? So P1 cannot release its resource A, and B, that means B cannot release the resource X. Then there get to be what? Indefinite starvation. The deadlock other name is nothing but, so deadlock other name is nothing but, if it is a finite starvation, it's not a deadlock. If it is a indefinite starvation, if it is a indefinite waiting, then it is a deadlock. So resource types: reusable resources, consumable resources. Reusable resources are process. Once a CPU given to P1, as soon as P1 is completed, CPU will be deallocated, and that CPU can be given to others like IO channel, IO devices, primary and secondary memory, databases, and semaphores. Consumable resources, once you consume, they have to be created newly, like interrupts, signals, messages, and any information in IO buffers. So, how the resources are allocated to processes? These are the steps you're supposed to take care. What are the steps? So, process P1, first of all, request for process P1, first of all, request for whatever the resource you're asking, like a memory, CPU, or IO, or any files. If Rx is available, that means your request is coming to whom? Your request is coming to operating system about Rx resource. About Rx resource. Then operating system cross verifies this Rx resource is available or not. If it is available, for example, let us say let Rx is free, it is not at all assigned to anybody else. Then your request, this is your request edge. This is your request edge. Then this request edge becomes automatically assigned edge. This request edge becomes automatically assigned edge. So request is coming from P1 this way, and assignment is coming from resource to process. Please remember this. Whenever an edge is going from a process to resource, it is a request. Whenever an edge is coming from resource to process, it is a assigned edge. So that's one meaning of that. Allocate the resources. Process will use that resource. Once the process get completed its execution, it releases resources. So what are the deadlock assumptions? Non-shareable resources, resource competition, and limited instances. As I told you, if it is a finite number of resources are available, then there are different processors who are competing each other to acquire the resource. So acquire the resource first, wait if it is unavailable, and release after completion. So basic terminology. What is a basic terminology? When I am talking about a process, pictorial representation, this is how you need to represent a process. When I am saying a resource, pictorial representation of resource like this. When I am saying a instance, one copy, two copy, then it is denoted with a dot. If it is a single dot, it is known as one instance. If it is a double copy, then it is known as two instances. Okay. Then another one is that request edge. This is a request edge. Whom to whom? Process to resource. Let us write symbolically. Process P1 is trying for resource X. And this edge is called request edge. This edge is called request edge. Second category of edge, RY resource, is allocated to P1. This is called assigned edge or allocated edge. Assigned edge. So let us see a few examples. If I am writing like this, R1, which indicates that it is a R1 resource with how many instances? With 0 instances because no copies are available. If I am saying that there is a R1 with one dot, which indicates that R1 has one copy that I can able to assign to some other process, whoever requesting. And the other one, R1 has 3 dots, which indicates that R1 has 3 copies. And sometime he will also say that R1, R2 has 2 resource and 3 resource, and R3 has 0 resource. This is also valid example. If not dot, he will be given a numerical like this. And another basic terminology is process P1 is requesting for one arrow, is requesting for resource Rx, and Rx has 3 copies. Process P1 requesting for only one copy. Process P1 requesting for one copy. So as there are 3 resources are freely available, one can be given to P1. So it is assigned because they are available. And another example, P1 is requesting for 2 resources of Rx, and Rx has 3 instances. One is already allocated to P2. See this example. So R1 is given, one copy is given to P2, still there are 2 freely available. As I am requesting, request always comes from process only. As I am requesting 2 copies, then immediately those 2 copies will be given to process P1. If not available, then P1 has to be under waiting. And the other scenario, there is a process P1. There is a process P1. There is a resource Rx. It has got 3 copies. One copy I have given to process P2. And process P2 is requesting for resource Y, which has got 4 copies. In one of the copy is given to process P3, and one of the copy is given to process P4. Assignment is edge always comes from resource only. And this is one copy is given to P1. So this is busy now. B stands for busy. This is busy and this is busy. No free resource available. No single copy available of resource RY, but P2 requested you. P2 requested for one copy. Why I am saying that one copy? Because one arrow only going, one copy. One arrow only going. One copy to RY, and immediately P2 is supposed to be under waiting because no single copy available. No single copy available. But you see that this one, So this one is not given to anybody else. Then you can give to P1, you can give to P2, but let us make it busy. In this case also, it is given to P5. So what is the meaning of this diagram? What is the meaning of the diagram? P1 requested for Rx. P1 requested for Rx. How many copies? One copy, one edge only. As it is having a free, it is having a one more copy is free, then immediately it is allocated to P1 and P1 started executing, it completes its task. But P2 is not like that. P2 got a one resource of Rx, but it is waiting for Ry. So in this case, unless P4, P5, P3 and P1 completes, P2 cannot start its execution because it is requesting for Ry resource. Let me show you one more example. There is a process P1. There is a process P1 requested two copies of Rx. Rx has three copies. You please comment whether is it possible to give to P1 or not. So I hope so you are clear now. As there are three free resources are available, three copies are available of Rx resource. As it is requesting for two copies, as they are freely available, can I give it or not? You can comment your answer. And one more example is here that this is the P1. This is the P1. Three arrows are coming, and this is a resource Rx with four copies, and this is a P2. This is the P2. One arrow, two arrows, three arrows. So in this case, what is the meaning of this terminology? So I'm releasing answer. P1 is requesting for three resources, but three are already allocated to P2. Now you decide that P1 will get a chance to execute or P1 will be under waiting. You comment your answer in the comments. And one more example. This is P1. It got three arrows like this from Rx. Rx has three copies. Three already given. Therefore, this is busy. This is also busy. This is also busy. Then there is a P2. There is a P2. One more arrow. What is the meaning of this? What is the meaning? P1 holds how many? Three copies of Rx. And P2 holds one copy of Rx because edge is coming from resource only. In the meanwhile, there is another process by name P3. It is requesting for four copies. When P3 will get chance? When P3 get chance? When P3 get chance? You know the answer. What is that? Soon after P1 and P2 completed execution, then P3 get a chance. Because once they have completed their execution, the resources will be deallocated and that can be assigned to P3. In this case, P3 is going to be under waiting state. So this is what is the meaning of basic terminology. So R2 has a two instances, R3 has a three instances, R1 given one copy to P1, then P2 is requesting one copy to R2 because one arrow only. And this is the deadlock indication. P1 is given to P1 is requesting for R1, but R1 is given to P2, but P2 is requesting for R2, and R2 is given to P1. So please see, requesting edge is always coming from the process. This is a requesting edge, and this is a assigned edge. And again, process is requesting to R2. This is requesting edge, and this is a assigned edge. So this is the basic terminology of that particular deadlock situation and how the resources are and the process becomes a cycle because of no free resources is available. One important thing is that once you allocate all the resources, whatever requested by the process, those resources will be deallocated soon after its completion of execution so that those resources can be assigned to some other process because some resources are reusable and some resources are consumable.